Assalamu alaikum, dear students. Dear students, this is our next video. This problem has also been selected from the book Modern Physics by Kenneth S. Crane. And currently we are dealing with relativity. Okay, relativity is a compulsory chapter of every book of classical mechanics. Sometimes this course is offered as a complete separate course, and sometimes relativity and cosmology. Okay, sometimes it is included in classical mechanics. Okay, like classical mechanics and special theory of relativity, or relativity and cosmology. Okay, anyhow, we first come towards the statement of problem. Okay, a physics professor claims in court that the reason he went through the red light, whose wavelength lambda is equal to 650 nanometer, was that due to his motion the red color was Doppler shifted to green, whose wavelength lambda is equal to 550 nanometer. How fast was he going? Okay, dear students, as usual we will first come towards the helping tools and then we will solve this problem. Okay, here, dear students, one thing needs to be noted that there are two wavelengths given. Okay, one is wavelength of red light, which is lambda equal to 650 nanometer, meaning 10 to power minus 9 meter, and wavelength of green is 550 nanometer, that is 550 into 10 to power minus 9 meter. Dear students, here red light comes first and green light comes later. Okay, so we will assume an arrangement that we will give first sequence or first arrangement, first number to red light whose wavelength lambda is equal to 650, while we will treat green light whose wavelength has been given as 550 nanometer as secondary source. Okay, so here two wavelengths are given. Definitely accordingly there will be two frequencies. Okay, so here for first wavelength or frequency we will use naught, which is sometimes written with O and sometimes with 0 as a subscript. Okay, so for red light we will use F naught, where naught is 0 or O written at bottom of S, F as a subscript of F. Similarly, wavelength lambda naught equal to 650 nanometer. Okay, while for green we will use simply F and lambda. Okay, that is without naught. Helping tools, tool number 1. Okay, this is the first tool which will lead us to our required solution of the problem. Okay, Doppler effect, electromagnetic waves, source approaching observer. Here F is the frequency measured by observer, while F naught is frequency measured in rest frame of source. Okay, F is equal to under root c plus u over c minus u. Okay, where c is the speed of light in vacuum and u is the speed of source relative to observer. Okay, this is the main tool which will guide us throughout this problem. Okay, f is equal to under root c plus u over c minus u f naught, where f is the frequency measured by observer and f naught is the frequency measured in rest frame of source. Okay, similarly u is the speed of source relative to the observer while c is speed of light in vacuum. Okay, second tool, we have used this tool many times in our previous problems. Okay, energy of photon equal to which is denoted by E is equal to hf. This alternatively becomes equal to hc over lambda. So what we see here, we see that in place of f, c over lambda has taken place. Okay, so from here we can conclude that frequency is equal to c over lambda. Frequency is equal to speed of light divided by wavelength. Okay, these two tools will be used only and we will reach our desired solution. Okay, so now we come towards our solution in a formal manner. Okay, f is equal to c plus u over c minus u f naught. Okay, f equal to c plus u over c minus u whole under root multiplied by f naught. Okay, no difference. We have taken this expression as our primary source for solving this problem. Okay, then this implies that if we shift f naught on other side of equation, then f over f naught is equal to c plus u over c minus u whole under root. Okay, then this implies that f over f naught is equal to 1 plus u over c over 1 minus u over c. What we have done, we have within the under root we have divided denominator as well as no sorry not divided, multiplied. Okay, we have multiplied. Rather, dear students, suppose we take LCM c, then c plus u will become in the numerator and c will become in the denominator. Okay, and in the lower side c minus u over c, then c will be cancelled out with c. Okay, because it will be then written as c plus u over c multiplied with c over c minus u. Okay, so quite simple. We move to next step. Here, dear students, in the next step what we have done, we have used tool number 2, second tool in place of f and f naught. Okay, because f is equal to c over lambda and f naught is equal to c over lambda naught. So we have replaced f and f naught with their corresponding lambda reciprocal values. Okay, and then we have taken square of both sides. Okay, by taking square of both sides, this under root will be eliminated, will disappear. Okay, so c over lambda square divided by c over lambda naught square is equal to 1 plus u over c over 1 minus u over c. Okay, same thing. Okay, here we have yet not written c plus u over c minus u. Okay, then this implies that what will happen, it will become c square over lambda square multiplied with lambda naught square over c square. Okay, then c square will be cancelled out with c square and we will be left with lambda naught square over lambda square equal to 1 plus u over c over 1 minus u over c. Okay, this implies that here what we have done, we have simply put the values of lambda naught and lambda, because in the starting of this problem we had assumed that light which is mentioned first time, which is mentioned at first place, will be taken as naught. That is, for that light frequency will be f naught and wavelength will be lambda naught. And light which is mentioned at second stage, for that light we will not use the subscript naught. Okay, so for second light, simply f and simply lambda will be the frequency and wavelength respectively. Okay, I think it is clear. Light which is mentioned firstly has wavelength lambda naught and frequency f naught, while light which is mentioned subsequently at second stage, for that light frequency is denoted by simply f and wavelength is denoted by simply lambda. Okay, so accordingly we have used values of lambda and lambda naught in this expression. Okay, and in next step we have done that c plus u over c minus u, this c will be cancelled out with this c. Okay, we will take LCM. Here it will become c plus u over c, here it will become c minus u over c, and in the next step it will become c plus u over c multiplied with c over c minus u, and c will be cancelled out, and hence 650 nanometer square divided by 550 nanometer square is equal to c plus u over c minus u. Okay, now we move to next step. In the next step what we have done, we have simply taken square of this and square of this. Here nanometer square will be cancelled out with nanometer square. Okay, so here units of 650 and 550 will be eliminated, will be cancelled, and we will be left with simply square of 650 and square of 550. Okay, so accordingly this implies that 422,500 divided by 302500 is equal to, okay, in place of this these two numerical values have appeared, and on the right side no change, the same has been reproduced. Okay, so in the next step what we have done, we have simply calculated this, okay, by dividing this on this, so it has become 1.3967 is equal to c plus u over c minus u. Okay, to this extent I think there should be no confusion. Okay, dear students, in the next step what we have done, the next step, this is same, we have not touched this 1.3967, it is quite okay. We have shifted c minus u on other side of equation. Okay, this is c minus u, and on the right hand side this is c plus u, and next moreover in place of c, speed of light, we have used its value. Speed of light has value 2.998 into 10 raised to the power 8 meter per second, but we usually take it as 3.0 into 10 raised to the power 8 meter per second. So if we do not write 10 raised to the power 8, then we will have to write 3 in this form. Okay, 3 along with 8 zeros. Okay, 1 2 3 4 5 6 7 8, 3 along with 8 zeros meter per second minus u is equal to again 3 with 8 zeros meter per second plus u. Okay, in the next step, what we have done, what we have done, we have done simply we have multiplied it. Okay, we have multiplied with this and this. Okay, when 1.3967 will be multiplied with 3 along with 8 zeros, then it will become 419010000 meter per second minus when it will be multiplied with u, then simply u and that value. Similarly, on right hand side we have made no changes, it is still existing in the same. Okay, right side we have just reproduced right side while we have simplified left side. Okay, now divide. Now dear students, what we have done, yes, we have done, this is meter per second and this is also meter per second. Okay, it means in the next step we have shifted this 3 along with 8 zeros meter per second on the other side of this equation. Okay, so from here we will take m meter over second as common, and this will become this minus this. Similarly, this minus quantity minus 1.3967 u will be shifted on other side of equation, but and then its sign will become positive. Okay, on the other side it will become plus, and when it will be shifted on other side, then u can be taken as common and 1 plus this will become on right hand side. Okay, now quite simple. In the next step we will subtract 3 along with 8 zeros from this figure, and we will add these two terms. Okay, addition of these two terms is quite simple, because simply we will replace 1 by 2. This is 1.0000 and this is 1.3967. So addition of these two will become 2.3967, while difference of this becomes equal to this 11,901 4 times 0 meter per second is equal to 2.3967. Okay, u. So this implies that we have to find u. So u will be kept on one side and this will be divided on other side. This will be shifted on other side, but here it is being multiplied with u, while on being shifted to other side of the equation it will become in the denominator. So u will become 496557776.69 meter per second. But dear students, usually we do not express speed in such a irregular manner. Okay, no doubt this answer, this reply, this solution is 100% okay, quite okay, but it is not looking pleasant. Okay, it gives a bad impression about the tutor. Okay, so we convert it in this form. Okay, because 4.96 will approximately become equal to 5. So we will get u equal to 5.000, or simply 5 multiplied with 10 raised to the power 7 meter per second. Okay, so I think this is the sign, this is equal and this is approximation of sign. Okay, so I am not very much sure about significance of this symbol, but I think it means that either this is equal to or this is approximately equal to. Okay, both signs have been merged in one sign. One is sign of equality is and one is sign of approximation, so it should be read as either it is equal to or it is approximately equal to. So u which we had to find out has become equal to 5 into 10 raised to the power 7 meter per second. And till next video, Allah Hafiz.